Okay, good evening everyone, and welcome to the institution's headquarters and to the James Sutherland History Lecture this year. Welcome to our online audiences too. My name is Kim Rochard. I am the Structural Engineering Team Leader at Historic England and the iStructD History Study Group Convener. I am the host this evening. Before we begin, I've got a few important updates. There's no scheduled fire drill. However, in the case that the fire alarm does go off, please exit the building via the nearest fire exit, indicated by the illuminated green running man sign. Once outside of the building, turn right and proceed to the assembly point, which is outside 42 Bastwick Street. If we're not inside the auditorium, the fire routes and exits are located at both ends on each floor. Copyright. To the institution's best knowledge, copyright permission has been provided for all material shown, and this broadcast is therefore presented in all good faith. If the copyright holder believes permission has not been forthcoming, then the relevant item will be removed, or by agreement an appropriate acknowledgement provided to accompany the recording. This event is also being live streamed, so we've got an online audience tonight. Following our presentation from Professor Dr. Stefan Holzer, there will be an opportunity for questions. Just a quick update for our online participants regarding questions. There is an Ask a Question tab where you can send through your questions. Questions can be shared at any time during the presentation. There's no need to wait until the end. Due to the number of participants both in person and online this evening, we will do the best we can to answer as many questions as possible, but there might not be time to answer all of them. And for any technical issues, please reach out to the events team using this or using the email address that your invitation came from. This lecture is also being recorded and will be made available to watch on demand in the next few weeks on the iStructD website. So just before we start, just a little bit about the James Sutherland History Lecture. The annual James Sutherland History Lecture showcases outstanding research in the history of structural engineering. The lecture is named after the late esteemed engineer James Sutherland, who was the first chair of the History of Structural Engineering Study Group between 1972 and 1992. James specialised in pre-stressed and precast concrete structures and gave the Sutherland Lecture himself in 1995. And from then on it took on his name. The lecture continues his legacy in promoting historical research in engineering. So I'd now like to introduce our speaker this evening, Professor Dr. Stefan Holzer. Professor Holzer has joined us from ETH Zurich, where he is a Professor of Construction History and Building Archaeology in the Department of Architecture. Professor Holzer's research is focused on the structural analysis of historic constructions, historic timber structures, and the history of scaffolding, centering and other temporary works. The lecture this evening will highlight how temporary works were used to provide access to work sites, facilitate material transport, and how they influence structural design. The lecture will concentrate primarily on scaffolding, lifting and vaulting in the medieval period. Please come to the lectern.
So thank you very much for the introduction, and it's a pleasure for me to be here today to give my lecture, which has the title, as you can see, Construction Site Essentials. So I will focus on the construction site. However, one can do that with respect to historical buildings. So by education, I'm a structural engineer. And many years ago, I found, first as a hobby and later on it became more and more important, I found interest in historical structures, and I tried to understand how historical structures work. And so the structure itself, the preserved structure, is the focal point of my research and of my work. And you can, of course, look at historical buildings or structures in various ways. So you could look from the point of view of art history, which is more interested in the representation of the client in the building, so the ideas that were expressed by the client in the building. Or you could take on a more architectural history perspective, which would ask for the design principles applied by the architect or by the builder or whatever that was in history. And of course, all of you are probably quite acquainted with the approach of the structural engineer, who would like to know how these historical structures work, how they perform, what is their mechanical behavior or their physical behavior. That's how I came across these topics, since when you study a historical structure, it is often so. I started to believe, in the beginning, I believed that if you can handle your finite element code, which was in that case my own finite element code, which I had developed myself, if you can handle that very well and you can do a very nice structural model of the historical structure, then you will be able to understand everything. And I came quickly to discover that this is not true, but that you have to understand basically the processes, the historical processes of how the building was assembled, the materials, of course, the historical materials, and what is behind the facade of historical buildings. And this brought me from structural engineering to history, where I'm now working. So, and the last perspective, of course, that's the one which I will take on this evening, is the construction site perspective, the worker's perspective, the craftsman's perspective. So how do we get that thing accomplished? How can we build that thing? How can we really achieve it? And that's the topic of the lecture. Now, the question is, of course, I cannot deal with everything, so I had to focus a bit. So I will tell you a bit what this lecture will be about and what it will not be about. So I will focus on temporary work, so things that have vanished, and like scaffolding, like centering, and as was already said in the introductory words, in lifting devices, cranes, and stuff like that. And this in the foreground here is also kind of a lifting device, right? So the next topic is which times should we cover? When I was asked to give this lecture, I was explicitly asked to focus a bit on medieval history, but it is, in my opinion, is almost impossible to deal with the Middle Ages without looking a bit into ancient technology as well, and also to see how it continued after the Middle Ages. There's no sharp break between the Middle Ages and early modern times. Until into the first third of the 19th century, the construction site didn't change almost at all. And therefore, it's useful to look also a bit forward into the 16th, 17th, 18th centuries if you want to look at medieval technology. And then, of course, which kind of structures are we specifically interested? There are many structures I could talk about. I have a certain focus on historical timber structures, but this is not the topic today. So I will talk mostly about masonry structures, especially masonry employing large blocks, and about vaults, which is recently one of my favorite topics, history of vaulting. So now the question is, if you are talking about things that have vanished, temporary works, so what are the sources that we have? There are, of course, some fascinating sources, which you see here in these two pictures. The one on the left-hand side, a preserved centering for a bridge, that's unique. I don't know another example of that, that's in Austria. 1639 is even dated. I guess they didn't know how to take it away, that's why it was left there. And the other thing is a contemporary model of a bridge centering from the Rialto Bridge, as you can see, which was brought to Nuremberg because they wanted to build a similar bridge in Nuremberg. So these are, of course, outstanding sources, but unique sources. It's difficult to tell a story only based on this kind of sources, since we don't have a large number of these sources. Then we can, of course, look to the building itself, and what is most valuable are unfinished buildings, buildings where the process of construction has stopped at a certain point. One famous example is the Parthenon temple, the pre-Parthenon temple on the Acropolis in Athens, where we have these unfinished drums of columns. We will see more of that in the lecture. But of course, it's sometimes very difficult to interpret the on-site evidence, the on-building evidence, unless you have some explanatory contemporary pictures, descriptions of any kind. So pictorial sources are very valuable. This is a pictorial source about ancient technology, lifting technology from Hieron of Alexandria. Okay, so with these preliminaries, I want to jump into my lecture. And the lecture will focus on 3 key challenges which are typically present in a construction site, or which were present in a construction site before the age of mechanization, so that is to say before the 19th century, mid-19th century. And the first challenge was, of course, to bring both man and material on site. And this is very straightforward, since the key object on the historical construction site was in fact the scaffolding, and the scaffolding didn't just serve for bringing people on site, but also to bring the material on site. So the typical view of a construction site, like the one which we have here, is a view of a construction site without any lifting device, or with just a minor lifting device somewhere in the background. So the key object is the scaffolding. It took me a while to understand that the historical construction site was principally relying on the scaffolding. It was much more important than today. Today we are used to view the scaffolding as something that brings people on site, but material transport, we think of the tower crane and stuff like that. And this is really an extremely recent invention, and the historic construction site relied mostly on the scaffolding. So it's worth to look at the scaffolding, and this fresco from a palace in Italy in fact shows many characteristic elements of the historical scaffolding. So it was built from cheap materials, either cheap or potentially reused materials, or it was made in a way that it could be reused. So these principal differences are there. What we see here is obviously a scaffolding that was made from cheap materials. And the typical scaffolding is the one which, where each of the levels, of the walking levels, is supported by vertical poles that are clamped into the ground. And this pole scaffolding leaves then the typical traces, like here in this 11th century church in Como in northern Italy, where you have these vertical rows of putlock holes, which correspond to the standards where then the putlocks were tied to the vertical standards. So there's nothing exceptional about that. But as I said already, the transport of material was also mainly relying on the scaffolding. As you can see in this well-known picture from the Tower of Babel in the mosaic in the narthex of Venice, St. Mark's in Venice, or in this contemporary 15th century illustration of a construction site. By the way, the wheelbarrow, which you see here on the right-hand side, was very unusual, or it was a rare device for most of the time of historical construction. It came up as a major invention only in the 19th century, and so typically everything was carried in hand barrows. And you can see in this picture that in both pictures that especially for the transport of small materials, the scaffolding was invaluable, or was essential. So everything was carried by men, by workers, by laborers on the scaffolding, on these walkways here. That's one of the central functions of the scaffolding, not just bringing people on site, but bringing material on site. And sometimes if you look at medieval pictorial sources, you will also find this kind of cantilevering scaffolding. I doubt that this was a standard thing. So we have to keep in mind that most of the medieval sources where we see scaffolding are 15th century, and 95% of those are representing the building of the Tower of Babel, which is a tower, which is a special structure where transporting the material via the scaffolding is more difficult. So when we have this kind of a structure, a tower-like structure, then this cantilevering scaffolding might have played a certain role as well, but then you need a separate lifting device as well. Either you bring up the material inside the tower somehow, on the staircases inside the tower, or you have a lifting device like the one shown here. And this construction site without any crane, without any lifting device, continued, as I already said, far into the early modern times, even into the 19th century. So this is a depiction of a construction site for reconstructing the Collegiate Church of Lindau on the Lake Constance in the 18th century. And you see still that there is no lifting device at all, and stones, even huge asras, are carried by hand barrows via the scaffolding. Another example of the same, more or less, here from a Swiss example in a Swiss castle, where you can see that this long walkway serves people to bring mortar and stones up to the place where it should be assembled. Now there's a special consideration if you want to use the scaffolding for the transport of materials, and if you also want to use it for storing materials, for example overnight, in densely built urban areas, then on the long run, this simple pole scaffolding, as you know it, with these rope-tied connections, is too weak. And so we see in the early modern age a certain development of the pole scaffolding, which relies not only on these poles, which are depicted here or indicated in red here on my picture, but so the poles then have only a stabilizing function. They are clamped, they are buried in the ground and clamped, so they serve as a bracing. Whereas the actual load carrying does not work through the long poles, but through short pieces, short standards or short posts that support then the ledgers. The ledgers are the horizontal beams parallel to the facade, and on top of the ledgers the putlogs are resting. So this is a much more stable and much more reliable scaffolding than this classical pole scaffolding, and this became very popular in the 17th and 18th centuries. And in fact, this was the typical scaffolding for building in urban areas. And as you can see, this is now also made from squared timbers, and the connections are done with iron clamps. So the idea is that the timber pieces can be reused and that they can be easily disassembled and reassembled. Here you see the comparison between the late medieval pole scaffolding with these rope ties and this more modern pole scaffolding. Okay, and for the workers, we have to go back another step, since for the workers, in fact, the pole scaffolding was not the only essential thing, but there's another type of scaffolding even more simple, even simpler than the pole scaffolding, namely the trestle. And I will show you now a few examples. Here you see the two directly next to each other, the pole scaffolding and the trestle. But in fact, the trestle played a much more important role on the historical construction site than we would typically assume. Of course, if you have to work at limited height, at 2, 3, 4 meters height, then it's natural that you bring the workers on site with, by means of a trestle, like here when they constructed the fountain of the big garden of the big park in Tivoli. Or here, so the typical, in the historical literature, the typical bricklayer's scaffolding is the trestle. And so in the back we have the pole scaffolding, but we have also the combination of both. And this would be probably insurance companies today wouldn't like these too much, but that's in fact also one of the key strategies that prevailed in the 17th, 18th, and also 19th century, how to work with pole scaffolding. You see again this pole scaffolding where we have the long standards that serve as wind bracing or bracing, and then the short poles or the short standards that support the actual walking level. And in order to minimize the number of putlock holes which you have to cover when you disassemble the scaffolding, in order to minimize the number of putlock holes and in order to minimize the number of stories of the scaffolding, then you use trestle scaffolding on top of the pole scaffolding to bring the workers to the adequate height. And that's not singular, but that's very often to be found, and it even found its way into mid-19th century textbooks. This is a textbook for students of the University of Munich, where they would study construction. And so in this textbook, it is advised that you should use these trestle scaffolding in combination with the typical classical pole scaffolding. And these are some maybe more spectacular and unusual uses of the trestle. So on the left-hand side, this is from Nicola Zabaglia's Castelli e Ponti, which is a book about temporary works in St. Peter's mostly. And this is how they renovated the mosaic in the apse of San Paolo fuori le Mura in Rome without touching the structure, without touching the marble-clad walls. So it was assembled as a huge stacked trestle. And the other thing is, I have a bit of doubt whether this was really like that, but it seems to be authentic. So when they built this steeple in this church, it's in fact the highest steeple of the canton of Lucerne. When they built this steeple, they built this long approach here via a trestle scaffolding. So the trestle, not to be underestimated. Today we see the trestle as something very simple if you want to paint your wall at home, but the trestle had really also a key role in historical scaffolding. Okay, but that's fairly easy, and now when it comes to lift really big blocks, then we have to go to some more advanced technology. And we see that here, when they lifted the huge slab covering the pediment of the Louvre eastern facade, a famous thing where the key point was that this slab was really very, very thin and very long, and it had to be handled with special care, like a raw egg, in order not to break before it was assembled. But I'm not going to this too much, but I want to show both the continuity between ancient technology, medieval technology, early modern technology, and on the other hand, also the breaks, the loss of knowledge between these different periods. One thing that turned out to be remarkably continuous is the way of attaching the load, the stone, to the crane or to the rope, where we have these different technologies. On the left-hand side, these are medieval specimens from the Maubronn Monastery Museum. So both the Louis and the tongs for lifting stones. And on the right-hand side, that's an excerpt from a 19th century construction book, which shows also some ancient technology. But you will see presently that this was carrying over without any break from antiquity to early modern times. Here on the left-hand side, you see the use of tongs, specialized tongs, in the Temple of Poseidon, is 5th century before Christ, in Sunion. And on the right-hand side, 2nd century AD, Porta Nigra in Trier, where obviously the ashlars were lifted by means of the tongs. And this indicates that at that time, these blocks were actually attached to a crane. So they were not lifted by means of ramps or sand, something carried up a slope, but they were actually hanging on a rope. So this means that in order to lift these heavy blocks from the architrave of the Temple of Sunion, you need a really powerful lifting engine as well. So we can see from evidence in Greek temples that after the late 6th century, these traces are reappearing and reappearing, so we can be quite sure that especially the block and tackle was also known and was also actively used in Greek ancient technology, and it continued into Roman and Byzantine technology as well. The other things, this on the left-hand side is really quite typical of Greek temples, this way of attaching the rope to the stone via a channel. And on the right-hand side, this is a huge block, a triglyph from the Temple of Nemea in Greece, where you can see my notebook sticking in it, and in fact it has a trapezoidal shape. So this was intended for a huge Louis, which was probably made of hardwood or something like that, not of iron or of bronze. It's really huge. This Louis hole is maybe 30 centimeters wide and 40 centimeters deep, so there was probably some wooden Louis sticking in it when it was lifted. And of course, then you need a crane, and there we have this wonderful picture, which probably most of you know from the Vatican Museum, this Hathiri relief, where you can see both the driving engine, this tread wheel on the right-hand side, and in the middle, the detail, the block and tackle, which enabled them to lift huge stones as well. And this is closely related to Greek philosophy, to Greek mathematics, to 5th century, 6th and 5th century before Christ, mathematics and mechanics, the knowledge how to use block and tackle and to understand the advantage of these things. However, this was almost completely lost. So we have almost no trace of block and tackle used after antiquity until the early 15th century. What, however, continued are these ways to attach the load to the rope. So you see here on the left-hand side, it's not very common, but on this picture from Colmar, you can see a Lewis sticking in the block. So obviously, they knew how to use the Lewis. And this huge block in the middle is from an 11th century church in Germany. It's a capital of a column. It's roughly 1 cubic meter of stone. So it's quite heavy, but not as heavy as to definitely require a block and tackle lifting technique. And it has this Lewis hole. And on the right-hand side, this is a little detail, tiny detail from the famous illustration of Jean Fouquet on the history of the Jews, where you can see a mason working out a Lewis hole on top of a block. Not a huge block like an architrave of a Greek temple, but at least a considerable block. And then the driving engines, they also continued into the Middle Ages. So we have, of course, the simple windlass, which you see here on the right-hand side. Then we have the tread wheel. This is one which we could actually date by dendrochronology to the late 15th century in Basel. And this is unfortunately undated on the left-hand side, this kind of windlass with a spoke wheel where you can pull with a longer lever than on the right-hand side. But in fact, all these lifting engines have the same power, more or less. Since in the tread wheel looks very impressive, but in the tread wheel you cannot walk up more than, say, 15, 20 degrees from the vertical. So in fact, the lever which you have, the length of the lever arm is quite limited. So although the tread wheel looks really impressive, the power of the tread wheel is not bigger than the other two. So, and as I said, in the Middle Ages, the knowledge about block and tackle was obviously lost, so we don't see any pictures of block and tackle before the 5th century. Also this Eastern Roman, Byzantine technology here for lifting this little column seems to be quite basic. And so what they lacked was really the free pulley. And they didn't understand the method anymore, and this is closely related to the fact that the architects or builders were no longer connected to academia, but they were practically trained on the construction side, and obviously it required considerable knowledge about theory to know how a block and tackle lifting device works, so we don't see any trace of that until the 15th century. However, even with such a simple technology, you can lift fairly complicated stones. Okay, if you just pull on the rope, the size of the stones is of course limited, and also the typical medieval crane for most of the Middle Ages was not slewing, so it was fixed in one direction, but you can still put a stone or assemble a stone with a non-slewing crane with the technology which is depicted. I like this picture very much, because you can see that obviously the crane is not slewing, but still it's possible to assemble the stone by this guy in the red circle who is pulling on a stay rope or on a rope that will push or will pull the stone sideways. So it's still, even with such a simple device, it's possible to assemble masonry from larger blocks. Again, here in this picture, you can see that it was quite widespread in the 15th century to use these cranes, which could not rotate, but still were helpful in assembling blocks. Not huge blocks like in antiquity, but medium-sized blocks. But then the 15th century is the big century of invention. We are used probably to think of the 15th century as a century where in Italy, Italian Renaissance came about with a lot of new ideas, influences of Eastern Rome, technology from antiquity transmitted through reading of texts of antiquity. But this observation that there was a technology revolution, this holds also for the other side of the Alps. This holds also for the parts outside Italy. So the 15th century was very innovative on both sides of the Alps. And one of the signature innovations of the 15th century, which then really caught the construction side, is the slewing crane, which we see here in the form of this crane on the ground with this tread wheel, and the tread wheel is attached to the pole of the crane, so it rotates with the crane and makes the crane more or less fully slewing. Another example of, at the same time, there is also this revival of ancient technology, which was probably transmitted through reading of ancient texts. So these are two examples of that. So again, once again, suddenly we see again the block and tackle, and we see also a very specifically ancient crane, namely a crane which has only a single pole that is held in place by stay ropes that can be also adjusted to incline the crane. That is described briefly by Vitruvius, but it's also described in more detail by Heron of Alexandria and by Pappos of Alexandria in the 1st century and 3rd century AD. So this is a typical ancient device, and it reappears on the construction site in the 15th century, and probably not by coincidence. On the left-hand side, you see the construction site of the Tempio Malatestiano, which was in Rimini, which was designed by Giambattista Alberti, and he is, of course, the author of the first early modern treatise on architecture. And he was well aware of everything that was written in Vitruvius and other ancient sources. And on the right-hand side, you see another illustration of this pole crane with a lot of detail, illustrated by Giovanni Antonio Rusconi, who was a kind of engineer in the Republic of Venice in the middle of the 16th century. And he was also very well acquainted with other colleagues who were working on editing historical manuscripts from the Vatican Library, translating the Greek into Latin or Italian, like Francesco Comandino, who edited the Pappos. And so obviously these 15th century and early 16th century architects, they got to learn about ancient technology via the texts, and then they revived these old ideas, and suddenly they had again this block and tackle technology and also this pole crane here. And as you can see, the pole crane then even found its way into one of the most prestigious construction sites of the 16th century. This is St. Peter's in Rome on the left-hand side, where you see in the foreground this huge pole crane. And it appeared exactly at the time when Michelangelo took over as an architect of St. Peter's. And the big change from Michelangelo's predecessors, Antonio da Sangallo, to Michelangelo was that the building material was changed from brick to ashlar, ashlar from Tivoli, travertine stone from Tivoli. So they needed powerful lifting devices, and it seems that they took this pole crane, this ancient idea of the pole crane, and brought it back into construction site practice in the 16th century. And here's another interesting example of this innovative spirit of the 15th century. This is from the sketchbook of an architect who worked at Strasbourg for the cathedral. And in his sketchbook, he even writes that he used that crane in Strasbourg Cathedral, not for the main tower, but for a little chapel which he added to the cathedral, so which is supported by wheels, so it can be moved. It's turning the engine, the windlass is attached to the vertical pole of the crane, and the crane is equipped with block and tackle. So this is 15th century high-tech, upper-end high-tech, cutting-edge high-tech of the 15th century. And in France, there's another interesting invention of the 15th century. So in France, this kind of slewing crane became really widespread in the 15th century. It's very simple. It doesn't have block and tackle. but it has on the back side of the crane, it has this tread wheel attached to the boom of the crane, which keeps the whole thing in equilibrium and enables very easily that the crane can rotate arbitrarily, which is not true for all the steering cranes of the 15th century. And this was really an extremely successful invention in that it was used until the 19th century in France. And not only in France, but mostly in France. So this became a kind of a signature French construction site element. This is the proof. So you can see here this same crane, which was invented in the 15th century. Probably we don't have any sources before the 15th century for this thing. And it was here represented in Mathurin-Jou's treatise on carpentry. Or on the right-hand side, you see a model of more or less the same crane in the Conservatoire des Arts et Métiers in Paris, which shows this, the use of this crane on 18th century major construction sites in Paris. And you find it also in the Encyclopédie of Diderot and d'Alembert and so on. So this was more or less the French crane then, from the 15th century until the 19th century, an incredible amount of continuity. And another type similar to the other one which we have seen before, then found its way also to other parts of Europe. Here we have the construction site of the Escorial in Spain, and you see an incredible number of slewing cranes. And if you have a closer look, so this is a very simple construction, again, very similar to this 15th century representation which we have seen before. This is depicted in the treatise of Furtenbach as the typical stonemason's crane, Steinmetzenzug, and it's basically the same that was also used 1 century before on the Escorial construction site. So, but now my most favorite topic is actually vault erection. And here we will go more to on-site evidence and not just pictorial evidence than before. So I want to focus on medieval vault construction, and it was one of the key achievements of the Middle Ages to reinvent vaulting or to rediscover vaulting. And of course the paradigmatic examples for this were ancient vaults, like here this ashlar voussoir vault from ancient Greek times, in fact, in Paestum, and on the right-hand side, the typical Roman opus cementitium vault. So we have to be aware that, of course, much more than today, these vaults were still conserved in the Middle Ages, and everybody looked at them, and it was the highest degree of perfection you could add to a building to cover it with a vault, and this would also make it fireproof, and so therefore it was clearly there was a high interest in vaulting structures, but the knowledge on how to do this was basically lost, and it had to be reinvented. The Roman vault relies very much on this opus cementitium, which is a mixture of maybe between fist and head-sized rubble and a lot of mortar, hydraulic mortar with pozzolana, and it relies exclusively on the formwork, and it's poured in horizontal layers, one layer of mortar, one layer of stones on top, and until it ends at the top with a horizontal surface. That's the way the Romans built it, and it relies 100% only on the scaffold, on the falsework, on the supporting centering, and the formwork defines the form of the vault. You see here on the left-hand side a view of a vaulted so-called basilica in the theater, ancient Roman theater of Taormina, where you can also see some of the pudlock holes which were probably supporting the centers for the falsework for this barrel vault. However, this was not the key reference for the medieval builders who reinvented vaulting, but they were more looking towards the provincial Roman technology. And in provincial Roman technology, we see also vaults of a different kind. Here on the left-hand side, you see the amphitheater of Saintes in southern France. And you see that this is a rubble vault with radially placed stone slabs. So it's different from this typical opus cementitium with amorphous rubble. It has these thin slabs which are oriented in a radial direction. And this is widespread in ancient Roman technology in France, and France was probably one of the places where vaulting was then reinvented in the 11th century. I show you an example from Switzerland, because you can see in this collapsed vault very clearly that it's also composed of radial stone slabs. And one of the first major buildings in France was the Abbey Church of Tournus, which was built during the first half of the 11th century, and it's one of the first entirely vaulted churches after antiquity, one of the first entirely vaulted buildings after antiquity. So they started in the east, here on the left-hand side, with the crypt, and then they built the western Galilee, this western narthex or porch, and they ended up with building the main part of the church in the middle, and almost everything is vaulted with either monumental barrel vaults or cross vaults. And we will have a look now first at the oldest vaults, which are in the crypt, and then at the vaults in the lower story of the Galilee, of this narthex, which are groin vaults. So in the crypt, it's very nice because you can see the traces of the formwork very easily with the naked eye. So we have these very coarse traces. Why are they that coarse? It's evident that these were not boards that were cut with a saw, but these were evidently short pieces, short logs that were split with the axe. So it was a very easy, very simple, straightforward process to create these logs like you do for your fireplace. And these logs then, but once the formwork was completed, a thick layer of mortar was applied to the formwork, and then these stones were set radially into that mortar layer, and then the joints between the stones were filled with mortar. So that was the construction technology, not exactly the Roman technology, but similar to provincial Roman technology, and they could leave it as rough as that, because probably they planned to plaster that over anyhow, and then you wouldn't see these rough traces. They might even be beneficial for the plastering, because the plaster would adhere better to this rough surface. So what was obviously the centering below that was very densely spaced centers, and then this overlapping, and it was even done like in the tiles in a roof. So there was the overlap of these short pieces at the places where they were supported by the centers. And the same way they also did what looks like a cross vault in the crypt, but it's not really a true cross vault, but it's basically a barrel vault with lunettes which reach up almost to the apex of the main barrel vault. And again, you can see the same traces. And for this, it's now very easy to reconstruct the building sequence or the whole process, how this crypt was built. This crypt has, in fact, an ambulatory and a central hall, and both were done in the same type of construction. What you can see here is a schematic representation of the height of the level of the individual boards. So you can see where they are joined or where they are overlapping. And of course, at each place where these boards or these logs are overlapping, there must have been a center. And so we have a very, very dense sequence of centers. That means that the centers can be very light because they don't have to support a huge load. We can use these short logs, which can be re-employed for some other purpose afterwards. And so it's possible to do this barrel vault. And in fact, there's one unique evidence, a pictorial evidence for 11th and 12th century vault construction, which is this detail of a relief from the Cathedral of Basel, where you can see exactly such a dense sequence of centers, and now this mason is attaching boards to this dense sequence of centers to build the barrel vault in this case. This is from the relief of Saint Vincent. He was a saint who was brought to Spain, and in Spain then they built a chapel for him, and that's the finishing of the chapel, which ends up with a vault. Okay, so for Tournus, we could then, of course, very easily reconstruct the building sequence. So obviously everything was also done completely with a complete centering everything. So first they put these these logs on these centers. Then they attached lunettes, and then they could erect on top of that the walls that looked more or less a bit like a cross vault in the crypt and like a barrel vault with lunettes in the ambulatory. And this technology of very densely spaced centers continued in Burgundy far into the 12th century. So we can see many, many buildings where we have these clear traces of very densely spaced centers, even though now the profile of the vault is slightly pointed, but still the centers are very close. We have these short pieces, very rough pieces of wood, which serve as a formwork. But now, if we go now to the Galilee, to this lower part of the western narthex of the church, the picture is completely different. First of all, this is a vault. It's a true groin vault. It does have more or less a horizontal ridge, and it looks very nice. So you don't see the traces with a naked eye easily. But for this, it's still possible to identify the traces of the formwork. What we do, in fact, is we did a geometrical scan, a laser scanning of this structure, and then we analyzed what we got from the point cloud, the measured point cloud. And so first of all, it's clear that they didn't work like the ancient Roman architects, that you had this over the diagonals elliptical centering, but they had obviously circles, only circles. So the Roman groin vault has horizontal ridges and has long boards supporting the load. That's how you could reconstruct this example is the Colosseum in Rome, how you could reconstruct the ancient Roman technology. But if you go back now to Tournus, it is clear that all these arches, so both the bounding arches of this vault compartment and the diagonals are all circles, but the bounding circles are stilted, whereas the diagonal circles are surbased. So we have a segmental arch on the diagonal and stilted arches around, which still enables to get more or less horizontal ridge, which was essential because you have the upper story above. And then if you have measured all these details and you can model them, then you can also model an ideal surface that would result from these circles. And if you just put a smooth surface between these bounding arches and you measure the deviation between that ideal vault surface and the measured surface, then you get the deviations, and this color picture on the left shows the deviation between the ideal smooth surface and the measured surface, and again we can see the traces of the boards. However, now we realize that there were longer boards, and obviously they were also a lot smoother than in the older crypt, and so it was obviously something like that. So you had these stilted arches around, the segmental arches in the diagonal, and then a more or less longer smooth boards that had to be cut by the saw. Also, they are also wider. This picture is not exactly Tournus, so they are also wider boards. So we could reconstruct that basically the centering must have looked like that. So first, it's also evident from the findings in situ that first of all the four bounding arches were built, and then they erected a separate new centering inside this square to build the groin vault itself, which goes a bit above the apex of the bounding arches, and then they used fairly wide, straight boards cut with a saw to erect this groin vault. So there was a considerable advance in technology. However, this had also its limitations, since if the span of these boards is too long, then the boards will deflect, and then you need to dream up something. Either you use very thick boards or you use some other means of doing it. Now we have another very important Burgundian church in Switzerland. It's Payerne. This is one of the main sites of Switzerland. If you ever happen to come to Switzerland, don't miss it. It's Payerne, 11th century church. It's the little sister of Cluny, but very well preserved. And what we did recently is also to measure this both photogrammetrically and with total station and laser scanning. So that's the outside view. Again, you have this kind of a narthex. The larger part of the church is vaulted with barrel walls, but the eastern parts, which you don't see here very well, but you will see them in the next picture, the eastern parts are cross-vaulted, groin-vaulted, and even there's one rib vault in the crossing. So these are the eastern parts which were probably erected around 1100. They are not precisely dated, but they must have been finished around 1100. And what you can see here now, it always doesn't look like a groin vault, but it resembles a bit a dome. You can see that the groins are clear in the lower part of the vault, but then they vanish towards the higher parts. And this has to do with the fact that these vaults don't have a horizontal ridge, but from the upper side, they look like that. They look almost like cupolas. By the way, it's not a rubble vault. It looks a bit like a rubble vault, but in the meantime, there was a strong tendency to go from rubble, from very coarse stones, to ashlar, to cut stones, and this looks only like rubble from the upper side, because, of course, what you see is the back side of the stone, which was not worked as diligently or as a detailed manner as the lower part. So if we map all these stones, we can see that these are courses of stones, and they are laid in individual, quite well-defined layers. So they are squared stones, but what you see here is the back side. So this gives it a bit the impression of a rubble vault, which it is not. But now, how do you build such a thing? First of all, the span is now quite considerable, so it's between 6, 7, 8 meters, something like that. And if you use, you cannot use straight boards because then you don't get this domed shape. So you have to use shorter boards, which is also good because you have to bridge a larger distance. So basically, there are two different approaches possible or thinkable. One where we have additional centering supports for each of these severies, these doubly curved severies, parallel to the formoid arch, so to the bounding arch, or orthogonal to it, either the left way or the right way. And now the question is, which was the technology that was really used? And the evidence, again, is very clear. So what we see here, again, is a comparison between the measured vault surface and a smooth vault surface, which then makes the traces, the board work imprints very visible. So this is, of course, I was, for 15 years, I was a professor of mathematics for civil engineers. And, of course, I liked all these mathematics-oriented methods where you can use least square fit with a smooth surface to the actual surface, and then it becomes evident that there were intermediate centers parallel to the bounding arches that supported relatively short boards. And in the upper part where you see this very smooth area, this is a repair, 19th century repair, where a hole in the vault was fitted with bricks. So that's not 11th century, but the rest is the original 11th century vault. And you can even see in the longitudinal section, that's the transversal section of the vault, you can even see a certain kink in the vault contour, in the lower vault contour, where we had this intermediate supporting center on which these short planks rested, which were used to build this a bit spherical or domed vault. The same is, by the way, also true for other early groin vaults. These are the two groin vaults in the heavily painted groin vaults in the Church of Sant'Abbondio in Como, which we have already seen on one of the first slides. Here it's quite certain that this vault was built around 1090, so a very early groin vault and also quite a big one. And again, on the left picture particularly, you can see very clearly that there's a clear kink in this severy halfway between the bounding arch and the apex, so there was another centering parallel to the formoid arches supporting these short boards. And I have currently a PhD student, Marius Pfister, who is working on Burgundy and on vaults in Burgundy, and even in these quite advanced oblong cross vaults of Ancy-le-Duc, which are considered some of the earliest cross walls on a rectangular, not square, but rectangular basis. He could also identify traces, formwork traces, and then, of course, also reconstruct the supporting structures with centers parallel to the bounding arches supporting this formwork for this very nice cross walls here, as shown on the right-hand side. So now the question is, the question that I also ask myself all the time, did everything change then with the advent of the RIB? Or was the technology already there before the RIB was introduced? And the answer is yes, second answer. Almost nothing changed with the advent of the RIB. So we see basically the same construction principles of ribbed walls as for the groin walls. This is again an early example of a rib vault from Switzerland. So the rib vault appeared around 1100 in the Cathedral of Durham and in Normandy and also elsewhere in Europe. So there was more or less around 1100 the rib suddenly appeared. And of course, there's one effect of the rib, which is new. The rib could serve as a support for the false work for the Severies. So here we have a proof where the historical, these laths supporting the masonry of the Severies are still in place. This is from the cellar of the castle of Chillon, this nice castle in the lake of Geneva. And so this means, of course, again, you need still a diagonal center to support the rib. And then, but then you can assemble the rib on top of the centering, and then you can use the rib as a support, as a kind of a lost centering or as a kind of a permanent centering for the Severies. And then you have these short and narrow pieces supporting the masonry of the Severies. Here they are also in cut stone with wide joints, with wide mortar joints. And this is why you don't need a continuous boarding, which you need only if you have small stones or a lot of mortar. If you have cut stones, if you have ashlar, then you can use this kind of support on individual laths. There's not the only example for that. There's another example in what is today Czechoslovakia. So again, these are all examples from the 13th century where we have still some of this formwork in place, and it tells a clear story how the vault was built and conceived. However, this was already quite usual in the 12th century, so it comes more or less directly with the introduction of the rib, comes this use of the rib as a permanent centering. This is a detail from the Cathedral of Noyon, which was built between the middle of the 12th century and the end of the 12th century. It's the first bay of the nave, the easternmost bay of the nave. And you can see that there is this kind of a strange plastered or mortared gap between the Severy and this former red arch, especially at the top. Towards the ends, it's vanishing because you don't need any support for the masonry in the more or less vertical parts of the Severy, but where it gets flatter, then you need some support. And then you see here this mortared gap. And if you look close, if you have a close look at Gothic walls up to the early 14th century, you will find many, many examples where you can identify this gap, not only at the former red arches, but it's a bit harder to see also at the diagonal ribs. So this was very common. Here's an example from Switzerland again, this church in Basel, which was transformed into something different after the dissolution of the monastery. And so we can get really close to the ribs. And again, you see this is one of the diagonal ribs. And you can see again this plastered strip, this plastered gap. And I was even able to measure it. It's 8 centimeters deep. So I was able to poke my little ruler in between the plaster and the ashlar, and it's about 3.5 centimeters high. So just enough to insert a nice board, which you can use to erect the Severies. So the main advantage of the Gothic vault compared to the Romanesque vault is that the pointed arch makes it a lot easier to get a horizontal ridge. So if you have a horizontal ridge, then you can use long, straight boards. And if you have the pointed arches, then you can achieve very easily that you still have a semicircular diagonal, but all the other arches are then slightly pointed and they will reach the same height. And then you automatically get this kind of boarding. So since the diagonal arch is longer than the bounding arches, the boards will then shift a bit in direction from top to the bottom, and this is exactly what you can also see in the masonry in situ in these buildings, that also the courses of the stones are shifting a bit. So you start at the top with the first board and then you put the other boards, and then you automatically get this kind of a nice formwork, which will also tell you how to lay your stones, your nicely cut ashlar stones, which then become popular around 1200 for rib walls in France. But even the method with the densely spaced centerings and the intermediate support continues into the Gothic age. So you see here this example from the Church of San Flaviano in Montefiascone. It's a 12th century church which was extended in the early 14th century, 1301. And you can see here in this plaster or in this mortar, you can quite clearly see the imprints again of a centering which looks very similar to what we have already seen 200 years before in Ancien-le-Duc and in these other late early and high Romanesque buildings. So now, of course, as a structural engineer, we are not only interested in the formwork, but also in the supporting structures. But there, of course, we can much less rely on actual evidence in situ, but we have to go back to pictorial evidence. These are some of the most well-known pictorial representations of centering from medieval manuscripts. Very simple centering because the span is very limited here. I could find a similar center in the citadel of Orvieto in Italy, where at least the horizontal beam is still conserved and where we can still see the notches for these diagonal supports. So for smaller spans, that's okay. Or if you have a very dense sequence of centers, you could also support your formwork with this kind of arches. Timber arches, and this is now one of my favorite pictures. Unfortunately, it's not medieval, but it's early modern, or these three pictures are all three of them early modern, and it shows centering as it was suggested for repairs on Gothic buildings in the 18th century. On the right-hand side, the right two examples, and the left one is from a early 19th century Austrian construction manual, where the author writes that just to know, I'm also representing the ancient way of doing walls. And what is interesting here is that this centering is always based on the ground. So the centering is not some structure hanging in the air high above the floor of the church, but you build a centering from the ground up to the top. Anyhow, you need the centering to assemble the huge stones, which are typical in the considerably sized stones of the Gothic cathedral, and you need some kind of a platform on top. So you always have a centering or a scaffolding, a temporary structure, which rests on the floor of the church, reaches up to the vault level, and then on the vault level you can erect the diagonal arches for the diagonal ribs, the diagonal centering for the diagonal ribs, and then you can build the vault on top of that. These are, as I said, early modern pictures, but we can be quite sure that the Gothic age used very similar centering. And there's another very nice, also early modern, but even older than the pictures, a description of a centering in Vincenzo Scamozzi's Idea dell'Architettura Universale. He describes a study trip which he did to Bohemia and then to Paris and then back to Italy. And on his way back from Paris to Italy, he passed through Langres in Burgundy. And the Cathedral of Langres had then some years before burned heavily. There was a heavy thunderstorm and it got hit by thunder and part of the roof collapsed and obviously even part of the walls collapsed. You don't see today where this damage really was. But he gives a very nice description of the centering, which was then used in 1615. It was used in 1600 to rebuild the walls of Langres. And he says, un armamento che faceva un tessuto di legnami grossi di rovi, so it was made from oak, huge pieces of oak, da piano terra fino sotto alla volta, so from the bottom up to the vault, così accanto alla mura di qua e di là per lo mezzo. So there were three rows of vertical supports, 3 rows of posts, one on each side and one in the middle. And then he says, altri molti attraversati in più ordini, so there was also cross, so horizontal ledgers attached to it, e poi de minori incrociati, so also wind bracing, St. Andrew's crosses, intanto che ne risultava fortezza grandissima a tutto l'ornamento. So this was an extremely solid structure. So as an Italian, of course, he was very impressed that they used oak for this temporary structure. But what is very interesting, we are now much closer to Gothic practice, that again, in this case, also the scaffolding was, or the centering was built from the ground up to the top, with squared timber, with solid connections, with solid wind bracing, and this was built just to restore the walls. In accordance with the other pictures which we have seen, this other one on the right-hand side, which I got recently from Etienne Amont, is a picture for restoration of the crossing of Notre Dame. So they planned the same thing, and so it was evidently, the idea was always that you put the centering on the ground. And this is a late, and of course in late Gothic things changed a bit because these fine meshed walls came up, and then you don't need any formwork anymore for the Severies because they can be done in brick, thin brick shells which can be free-handed, can be assembled free-handed, but you still need to support the ribs with appropriate centering, and this is a model of a centering from Nuremberg. This was a masterpiece of a mason from Nuremberg, and they always had to solve the same problem, this ground plan which is depicted on the left side, and then they had to devise the centering, or they had to design the geometrical shape of the centering for this kind of star vault with these trapezoidal compartments. But what is interesting for us in our context is that each point where these centers meet is supported by a vertical post. So again, very much everything supported from below and not some fancy structure hovering somewhere in the air. And this is further confirmed by other pictorial and archival evidence. What you see here on the right-hand side is a detail from the well-known Tower of Babel of Peter Bruegel, where you see again that the centering for the walls is supported from the ground. And on the left-hand side, you see a comparison between a centering that is supported from the ground, from the floor, and a free-spanning centering. And this is, in fact, from a letter of Galeazzo Alessi, who was the architect of the Basilica of Carignano next to Genoa. And he explained he didn't go there very often. He was based in Milan, and he directed this Genoese construction site from distance by lots of letters. And there he writes, I'm not going to use the conventional way of the centering, which is supported from the ground, because this will be too much of an obstacle for the operations going on the ground, but I will use the centering on the left-hand side, which is free-spanning. So this was something innovative, unusual. He says, I have one guy who knows this kind of centering, and this was, by the way, a direct copy from what was used by Antonio da Sangallo in St. Peter's in Rome. So this is, again, ex negativo, a proof that this free-spanning centering, which is shown on the left-hand side and which came basically from bridge construction, was very unusual for buildings. So for the building, we usually had the centering supported from the ground by long vertical posts. And even in St. Peter's, where we had the first experiences with this wide spanning, free spanning, not supported from below centering, Even in St. Peter's, for the smaller walls, the barrel walls, you can see that even in the middle of the 16th century, they were still using ground-supported centering, very much the same as was probably used in the 15th century, 14th century, 13th century in Gothic cathedrals. So the technology carries over from the Middle Ages to the early modern, great early modern projects. Okay, now I didn't cover some topics in this lecture because my time is over, and that's my last slide. So what I didn't cover here, and which would have been a really interesting topic as well, is bridge construction, of course. And I show you on the left-hand side these 4 pictures, 3 of them bridges, and the last one is St. Peter's in Rome, according to the fresco of Giorgio Vasari in the Sala dei Cento Giorni in the Palazzo della Cancelleria in Rome. So this is how the barrel walls, the huge barrel walls in St. Peter's were built. So this was, in fact, really a free-spanning center, but this was an extremely great innovation of the early 16th century, and it is very closely related to contemporary bridge building. So I didn't cover bridge building. Because most of the evidence is, in fact, early modern or even 18th, 19th century, and this was a bit beyond the time scope of my lecture. But if you want to know more about that, I can just recommend to read my book. Maybe it's a good reason to learn German now. Maybe it's not the best idea to read a 500-page book, the first thing, with very specialized vocabulary. But maybe you just go through it, you just browse it, you just look at the pictures. You will find many pictures about bridge construction, where these free-spanning centers had, of course, a raison d'etre, because the river carries timber pieces in high water, there are floods, and then for a bridge, a free-spanning center that is not supported from below by vertical supports is, of course, very advantageous. And so in bridge building, these centers were much more common than in buildings. But of course, a bridge usually also has solid abutments, and then it's much easier to do this free-spanning centering, which then became a trademark of French bridge engineering of the 18th century. Even though in other cases, the centering, as in the picture on the lower right, the center was still supported from below, even in situations like this huge gorge. But it's really difficult, and where the building of the centering was the essential achievement of the whole bridge construction. Okay, I hope that I could give you a little overview about our research results and our research activities in this field, in this elusive field of centering and other temporary works. And now I'm happy to answer your questions. Thank you for your attention. Should we sit here now? Yeah.
Quite a fuss in this country about the idea that Gothic architecture was stealing from the Saracens, which is the title of a well-known book. From what you said, there's not much evidence that the ribbed vault was stolen from the Saracens, or is that...
No, I think this was a new Western invention, and the Gothic vault is so closely tied to the Romanesque vault. So from the optical impression, one gets the idea that the Gothic vault is something completely different from the Romanesque vault. But the evidence which I have shown is that the construction technology, in fact, is identical. Yeah. It's completely continuous, and so there's a variety of vaults in the 11th century, even with considerable spans, not huge spans, but maybe 6-7 meters or up to 10 meters in the Cathedral of Speyer. And this technology more or less goes seamlessly into early Gothic, and it's then refined, and the advantage of the rib is taken, especially in the early Gothic vaults. The rib, as I showed, is also supporting part of the formwork, but there is no break. So the only thing that comes new is the pointed arch, but the pointed arch was already available in Burgundy in the 11th century. So the big church, the third church of Cluny, had a pointed barrel vault. So if that was a Saracen influence, okay, then maybe, but there's nothing beyond that.
Thank you.
Super. We've got a few questions online this evening. I can work out how to open that up. Did ancient temporary works technology limit size and height of buildings?
Yes, that's a good question. So for sure it limited the size of the blocks. So if we speak specifically about ancient, in the ancient world, in the antiquity, the crane was typically standing by the side of the building. So if you have a pole crane, so the hugest pole cranes that were ever erected, so this kind of cable-stayed pole, long pole, this was the most powerful lifting device according to Vitruvius. And in early modern times, in shipbuilding in France, they were assembling this kind of poles 40, 50, 60 meters high. And then this would, of course, limit the building. And if they had the same technology already in antiquity, this would limit the building height to this. But the typical ancient building isn't that high anyhow. So you could assemble it with a normal pole crane or this kind of shear legs, also cable stayed. So the height was not the most important factor of an ancient building, of a building from antiquity.
Fabulous, thank you.
Sorry, can I come back and get on that?
Yep, just a second.
I mean, the Romans did lift some prodigious blocks. I think the big stones at the top of the of Trajan's column, something like 120 tons.
Yes.
And I believe there's a block in the pediment somewhere in the Middle East.
In Baalbek, yes.
Yes, that's right, 300 tons.
They didn't have to lift that. That's close to the earth, so that had to be transported only horizontally. But of course, the capital of the Trajan's column had to be lifted, and it was possible with block and tackle technology, certainly. But I guess there was no crane, but there was probably scaffolding, like for the monument in London, a scaffolding that was covering the entire column, and then something that could be moved sideways or something like that at the top. At least that's the technology that was used in early modern times for building these tall structures and for lifting monuments, equestrian statues and stuff like that.
So you're pretty certain that a block and tackle was used for those?
Yes, definitely for Roman times, definitely.
Right.
We have this Hatiri relief, which is 1st century AD, and we have all the descriptions of block and tackle, all that theory available. So for ancient times, there's no doubt about it. And we have these huge Lewis holes in huge blocks that are really heavy, much heavier than a Romanesque capital. So for ancient times, there's no doubt about block and tackle.
Yeah.
After 515 before Christ, approximately.
Yeah. Thank you very much. Yeah.
You're welcome.
Super. Any more questions in the room?
many.
Thank you, Stefan. That was amazing. I would love for you just to carry on and tell us about bridges as well. You showed in your model of the arcades all centred out, you showed all that centering in place at once. Do you think there's evidence
Yes.
that it would be centred all at once rather than progressively?
Yeah, we would of course suppose that you do it section by section, and you can reuse the centers and you can reuse the formwork. But in fact, those formwork imprints are so clear that you can see exactly the overlap. So we are quite positive about the fact that at least the entire ambulatory was done in one run, because everything is overlapping from one end to the other around the entire ambulatory, so it must have been done in one run, in one go, more or less, right? And there's no other joint or anything visible there. But the interior part of the crypt, the hall part of the crypt, that could have been done in a second attempt or in a second phase. But of course, the idea would be, especially for these pointed barrel walls, which are also in the refectory of Tournus and other buildings in Burgundy, we would suppose that you have light centering and short pieces, short boards, and you erect maybe 5-6 centers in a row. You put the formwork up, you vault the first part, and then you move the centering like it was done in King's College Chapel in Cambridge. So you move the centering from one part to the next. This is a standard procedure later on. It was also done in Leon Battista Alberti's Sant'Andrea in Mantua. They also vaulted one bay after the other, moving the center. So especially if you have this light centering and this easy vaulting material, you would expect that you would do it in sections. But maybe this was also a step that first had to be discovered. But in this case, in this peculiar case, we are quite sure that it was done in one shot.
Fantastic talk. Thank you for this. It's been really fascinating to see how our ancestors built these incredible structures. I have a question. You hinted at it. I just want to ask, it sounds a bit strange, but it's really how we evolved and what was the major turning point when we stopped doing this. You mentioned it's like 19th century. Was it gradual or was it sudden? Were they using technologies or borrowing from, realizing that actually no, we know more about these materials now. We can do these frame structures, for example. That was an invention of the 19th century, and then it suddenly changed. Was it sudden or was it a gradual thing? Or it's I'm just intrigued about how our technology changed so rapidly after using this kind of stuff for literal thousands of years. Suddenly, bam, things changed.
No, it was quite gradual, nevertheless. So this French crane, this simple turning crane, I can still show proof that it was still used around the middle of the 19th century in France and also elsewhere. But new machinery then came up very slowly. So also engine-driven cranes came up really, really slowly. The steam engine is not optimally suited for a crane because the steam engine needs to run all the time, first of all, and its power is dependent on the number of revolutions per minute. So the steam engine is not a good engine. So the big revolution in lifting technology came only with electricity around the turn from the 19th to the 20th century. And these tread wheels, they were very common throughout the large parts of the 19th century. So yes, it was a gradual change. There were some attempts at a more radical change. There were also patented solutions for new lifting devices. There were sometimes entrepreneurs who tried out new engines and new ideas, but the big change came around only from the turn of the 19th to the 20th century. So I could have included most of the 19th century into this lecture, and we would still have seen the same devices, the same technology, essentially millennia of continuity. I tell always my students, the history of construction is not so much a history, but it's more a story about unchanging habits for centuries and centuries. Unchanging technology.
Should we just take an online question? So considering the large scale of buildings between the 13th and 19th centuries and the lack of modern tools, how did they manage to calculate areas and maintain accurate dimensions? Were there specific instruments or techniques they relied upon?
Okay, that's not really my main area of expertise. I know that surveying devices were extremely good already in the 16th century. So, for example, Specklein, who was a military architect from Strasbourg, he surveyed the city walls of Strasbourg, which was a 30 kilometer per meter. And at the end, he ended up with a difference. He reported that very proudly in his book. In the end, he ended up with a difference of 20 centimeters or something like that. So they had quite precise measuring devices, especially for measuring angles, already in the 16th century, and they did very careful measurements. And so I can only say that probably in the 16th century, technology for precise measuring was around, but medieval buildings are typically not very precise. So if you measure them, you always find that right angles are not really right angles, and things that look straight are kinked and stuff like that. So in the Middle Ages, precision, it looks very precise, but if you have a close look, most medieval buildings are rather imprecise.
Any more questions in the room?
Yes, back there.
Hi, thank you for the talk. During your research and studies on what you presented, did you come across any recorded failures of temporary works? And at a later stage, did you come across any better versions of a failed temporary works solution they had?
So I do come across several reports about workers' scaffolding collapsing. This is for sure. And of course, then the worker was always miraculously saved by God's action. But reports about, you are more thinking about centering and stuff like that. At the moment, spontaneously, I don't remember any report about a centering that collapsed or something like that. But there are some things like that, but I don't know of any case where this had a considerable influence on centering design. Rather, there are reports about failures of structures and then also strutting, especially of bridges. There are also drawings of bridges that were strutted in the 17th, 18th century, medieval bridges that were threatening to collapse, but that's a different story. So it's not about collapse of the temporary structure. No, at least for the moment, maybe if I think for a while, I will come up with an example, but for the moment, I don't have one.
Okay, we've probably got time for one more question.
There's one more back there.
Hi. My question is on, do we know very much about the design, so sort of the form finding of these arches and centerings, and then how they would make sure that they could actually make the centerings exactly to that curved radius and so on?
Mm-hmm. That's a very good question. That's a lecture of its own. I can give a brief version of it. So, first of all, centering design, especially for huge centers, for bridges and stuff like that, it was very closely related to roof truss design. So there was a lot of experience around for roof trusses, also wide span roof trusses, and a typical Italian carpenter would design centering for a bridge or a huge vault very similarly to a roof truss. So, for example, Old St. Peter's had a span of 24 meters, the nave, and to span 24 meters with rather low roof pitch is a challenge, and it's the same technology which the Italian carpenter used for building this kind of roof trusses reappeared in things like this centering for St. Peter's, which I showed. And same for the other side of the Alps. So the technology that was available for roofs was then taken over to centering. But the question, how did they dimension the individual pieces of centering? This was, of course, also an important question, and which also was in the head of the early engineers. And the first traces of attempts to dimension computationally the sizes of the individual members of a centering, they are 18th century. So Pitot, for example, the French engineer from Montpellier, he wrote an article about how to, he used some kind of graphical statics to determine the loads in the individual members of the centering, and then he tried to deduce the necessary dimensions of the individual pieces. And this became more widespread towards the end of the 18th century, but on the other hand, to dimensional centering is very much dependent on your ideas about the mechanics of arches and walls, and the mechanics of arches and walls only got sufficiently developed during, I would say, from the beginning of the 19th century to the middle of the 19th century, with works like Navier, Coulon, and Navier, and stuff like that, and so the preconditions for really reliably dimensioning centering was depending on wall theory, and this was not available before the middle of the 19th century, Moseley and stuff like that. And then there was still in the practice a strong reserve against dimensioning of centers in a numerical way, because they said there are always so many difficult influences, or there's so many aspects which you cannot easily catch computationally, that it is better to rely on empiricism, to rely on experience when designing even wide span centerings, than to rely on computation. So computationally dimensioning centering is essentially a 20th century achievement. It was not even in the most part of the 19th century. It was sometimes suggested by some people, but then violently disliked by others, because they said it's so difficult to get hold of the mechanics of walls and all the details that enter into wall construction, that it's better not to design the centering computationally.
Fabulous. Well, thank you very much for a wonderful lecture this evening.
Thank you for listening.
It's really been quite a whistle-stop tour of historic construction sites with some absolutely fabulous images to sort of demonstrate these to us. Particularly fascinating for me was how you can use modern survey techniques to find tiny kinks in the structure which show us where the temporary works were. Thank you.
Thank you.
You'd be welcome back anytime to talk about bridges.
With pleasure.
I'd like to thank both our in-person and online audiences for attending tonight. And again, the lecture's been recorded and it will be available on the iStructE website in a few weeks' time. There will now be drinks and canapes upstairs, but maybe we can thank Stefan one more time.
Thank you. And I will be available for further discussions. Show in many cases, I could show just superficial stuff, more detail for such a lecture. It's also important to do the same.